The topic is solving differential equations by separation of variables. Let's look at the definition. Definition says a first order dE of the form dy dx is equal g of x times h of y have separable variables. In other words, we can use method of separation of variables. So if you can write dy dx as some function of x times some function of y, then we can use the separation of variables. The method will be, also you can always move things diagonally. So what I do, the goal is to put all the x's and the dx's on the right side and all the y's and dy's on the left side. So this equation becomes, see, the dy is on the left side, I'm not going to touch it, g of x is on the right side. Now to move h of y to the left side, you can always move things diagonally. So h of y will go to the denominator, and then d of x can move diagonally, so it's going to go this way, so you'll have dx, and then all you do is you integrate both sides. Alright, so let's do example 1. So let's try to solve this problem. Dy dx is equal cosine of 7x. Alright, we're looking for y. So again, we want to have all the x's, all the functions of x, and dx's on the right side, and all the functions of y's and dy's on the left side. So I need to move dx to the right side. And again, you can always move things. As long as it's product, you can move things diagonally. So I'm going to move dx to that side. So dy is equal cosine 7x dx. Now all we do is take integral of both sides. Integral of dy is y. And integral of cosine of 7x, this is cosine of u. This is the same thing. Let me do it the quickest way. Well, let's do substitution so you can see it. So u is equal 7x, du is equal 7 dx. So dx is equal du over 7. So this is going to be equal integral of cosine of u dx is equal du over 7. So y is equal 1 over 7 cosine of u du, which is equal 1 over 7. Integral of cosine is sine. So sine of u plus some constant, which means y is equal 1 over 7 sine of, replace 7u by 7x, sine of 7x plus c. So that was a pretty easy example. So let's do example 2. So example 2, dy dx is equal e6x minus 9y. So again, going back to the definition, see, we try to write e to the x minus 9 to the y as a function of x times function of y, and if you look at the dE, you can see that this is just e times e to the 6x times e to the negative 9y. Okay, now we're trying to put all the x's on one side. Again, you can always move things diagonally, so dx can go diagonally to the right side. So dy is equal e6x dx, and then e to the negative 9y can go diagonally to the left side. So this will be e negative 9y, and then we can integrate both sides. Now this means I'm just going to move e negative 9y to the numerator. So that would be e 9y dy is equal integral of e 6x dx. By the way, those are easy easy integrals, instead of using substitution, u equal 9y, you can always do this. You can just multiply. Well, let's do that one because I don't want to confuse you. Alright, so here the u will be what? 9y. Du will be 9 dy. So the dy will be divided by 9. And so left side will be integral of e to the u. Right? The u is 9y. Replace 9y by u. And then dy is du over 9. Always solve for dy. So this is du over 9. Now same thing here for the right side. I'm going to put a u equal 6x. So du will be 6 dx. Solving for dx will be du over 6. So I use both of these. So this will be e to the u, and the dx is du over 6. Now I'm going to take the constant outside. 1 over 9 e to the u is equal du is equal 1 over 6 integral of eu du. On the left side, du happens to be 9y. So, well, integral of e to the u is eu. Eu is equal 1 over 6. Integral of e to the u du is eu. Remember, it's not the same u. If you want to call them different u or a v, it's fine. So this will be 1 over 9 e to the u happens to be 9y. So e 9y is equal 1 over 6 e 6x plus some constant. Don't forget the constant here. So you can rewrite the equation. If you want to rewrite it, let's rewrite it here. You can rewrite it as 1 over 9 e 9y minus 1 over 6 e 6x equals some constant. Or if you want to solve for, so this is implicit solution. You can write it as an implicit form. If you want to write it explicitly, solve for y. So this will be what? 1 over 9 e 9y is equal 1 over 6 e 6x plus c. Multiply everything by 9. You'll get e 9y is equal 9 over 6 e 6x plus 9c. Let's call this c1. So this is some constant c. Now take ln of both sides. If you take ln of the left side and ln of the right side, you'll get 9y equal ln of 9 over 6 e 6x plus some constant c. I'm calling c to be equal 9c1. c is 9c1. And then divide by 9 and you're done. So y is equal ln 9 over 6 e 6x plus c, everything over 9, and you're done. So this is the